Hi, I'm Mr. Huber, and in this video we're going to talk about problem 6. Look, in problem 5 we looked at functions of this type. Well, plus minus, you can clearly see the plus and the minus here, plus minus, minus u. Well, I used minus u here because, for example, in this one, x minus 4, the u would be 4. Okay, in this one, the u would be minus 4 because minus 4 is plus 4. Okay, just keep that in mind. So I've prepared a GeoGebra demonstration here. Look, this is the original parabola. Okay, you can clearly see that because it's 1 to the right, 1 up, 2 to the right, 4 up, 3 to the right, 9 up. And you could write it like this: 1 times brackets x minus 0, whole thing squared. It's nothing but x squared here. Now look, as I change my u to let's say 1, it will be shifted, translated to the right. I can go to 2 if you want to. Well, very, very fiddly here. Here, you can shift it to 2, so it will be shifted to the right. It will be translated to the right horizontally by 2 units. So it's x minus 2 squared. Why is that? Because when you plug in 2, this will be 0, and that will be your lowest point, as we discussed before. Now let's go to the other side. Let's, for example, go to minus 2. So when you plug in minus 2, it's x minus minus 2, so it's x plus 2, and that means it will be shifted to the left, you see? Or let's go to minus 3. Here we go. Shifted or translated 3 units to the left. Now let's put it back to 0 here. And you see I've introduced the coefficient in front of here. So I could go to a negative parabola here. This is the original negative parabola. And again, I can move it up a bit. I can shift it to the right, or I can shift it to the left. As I put it here on minus 2.5, that means it's x plus 2.5 squared and a minus 1 in front of it. So it will have its highest point at minus 2.5. Okay? And as I go over here, let's say 2.7, it will be shifted to the right by 2.7. You see the minus here. Well, here, it's going to be a plus. So when it's a plus, x minus minus 3, x plus 3, it will be shifted to the left because you need to plug in minus 3 in order to get 0, which will be the highest possible value for a sad parabola. Okay, let's go up to 1 again and put it back to 0. So this is the original parabola, the happy one, and this is the original sad one. Okay, now look, I've introduced the vertical stretch and vertical shrink. So if as I'm below, let's put it back to 1 first and switch on A and B. Look, 1 to the right, 1 up, 2 to the right, 4 up. As I stretch it vertically, for example, I multiply everything by 2. So instead of going through 1, 1, it goes through 1, 2. Instead of going through 2, 4, as in the original parabola, it goes through 2, 8. Or if I go down to 0.5, for example, everything will be halved. So instead of going through 1, 1, as in the original parabola, it will go through 1, 0.5. Or instead of going through 2, 4, it will go through 2, 2. Now look, you can put in a horizontal shift here too. Look, this is now a parabola that has undergone a vertical shrink, okay, it's times 0.5, and it has been shifted to the right. Or we could shift it to the left, here. So we have two parameters here that make this parabola move. Well, it's always a horizontal shift here, a horizontal translation. So it's x plus 2 squared, okay? So that means if it's x plus 2 squared, you need to plug in minus 2 here. You need to plug in minus 2 in order to have the lowest possible value. If you go to a negative, a sad parabola, okay, same thing, it will be shifted to the left, and it's a vertical shrink again. Okay, so you can shift it from right to left. So if you subtract a positive number, it will go to the right. If you subtract a negative number, which will result in a positive number here, it will go to the left. Okay, I hope it wasn't too difficult. See you in the next one.